Welcome back to the Lava Academy podcast, your monthly dive into the world of volcanoes, lava, and the forces that shape our planet. We're a team of lava enthusiasts based in Reykjavik, Iceland, part of the crew behind Lava Show, the world's first live lava show where we remelt real lava and pour it out in front of a live audience. But this podcast is where we go deeper into the science, the stories, and the people behind the eruptions. Each month we'll bring you interviews with a range of guests, from leading geologists and volcanologists to locals who've witnessed eruptions up close. We'll cover everything from the science of how volcanoes work and the tectonic forces shaping Iceland, to the ongoing activity on the Reykjanes Peninsula, historic eruptions, and the ways in which volcanic events impact people and communities. I'm Ian McKinnon, your host, former primary school teacher from Scotland, now living in Reykjavik and playing with lava for a living. And I'm on my own again this month. At least I don't have a co-host this month, but I do have somebody coming to join me, and I think we'll head over to that interview right now. So we are joined today by our special guest, Mr. Glen L'Estrange, who is a geologist and research assistant at the University of Iceland.
Thank you very much.
Hello, Glen.
Thank you very much for having me. Thank you. Hello.
So tell us a little bit about yourself and kind of like, how you've come to be here a little bit.
Yeah, so yeah, I'm a master's student at the University of Iceland and also working as a research assistant as well alongside that. So I came to Iceland originally back in 2016. I just fell in love with the place, the scenery, the volcanoes, of course. I then studied them back home and decided I wanted to delve even further into volcanology. So here I am back doing master's studies. And then, yeah, working alongside some great professors as part of a research team, researching some of the biggest eruptions here in Iceland in historical times.
And the kind of main focus of your attention at the moment is the Eldgjá eruption. So for folks listening who may not really know an awful lot about Eldgjá, can you give us a little kind of insight as to what it is and the significance of it?
Yes, so Eldgjá is one of Iceland's biggest historical eruptions. So it occurred in around the year 937 to 39. Some even say 940 as well. It occurred over 3 years. It's a massive eruption. Featuring both explosions underneath the glacier from underneath Middarsjökull, where Katla is sat, extending all the way out through the highlands towards Vatnajökull. So nearer to Grímsvötn and Urriðajökull, those sorts of volcanoes. So this eruption, as I said, one of the biggest eruptions in historical time. It produced massive amounts of lava and both also ash, ephra, as well. So something which it's good to have a nice overview of and an understanding of, just in case things decide to change in the future in that area.
Because, for those who are not aware, the kind of area that you're talking about there, that range of like places that you just gave us is a pretty significant chunk of land. Yeah,
so the fissure itself, it covers a distance of about 75 kilometers. So it's massive. It's discontinuous. It's not one whole fissure, but the area itself, the length itself is one of the biggest fissure eruptions here in Iceland. To sort of put that into perspective, the eruptions which we're currently seeing on the Reykjanes Peninsula only are about 5 kilometers long at their maximum length. So yes, pretty big stuff.
Yeah, and if you compare that to, one of the other ones that people might be familiar with who are listening to the podcast might be like Eyjafjallajökull.
Yeah.
What would it, in comparison to that, would it have looked anything like that, or would it be something just totally other?
Yeah, this absolutely dwarfs Eyjafjallajökull. the actual eruption itself it's considered to be small from Eyjafjallajökull because we are talking on a huge scale here. It would have sort of looked the sort of explosive phase in the early phase of the Eldgjá eruption would have looked similar to the Eyjafjallajökull eruptions, be it coming from underneath the glacier. We then also had extension out from the glacier, and so no more ice. The style of eruption was slightly different as it progressed throughout time. So yeah, similar but also different as well.
Yeah, so you would have seen things that are familiar from other eruptions, but just kind of like a kind of weird continuum of like going from one thing to the other to the other.
Yeah. So this eruption, I mean, it occurred over, they think about 3 years. And yes, it started in the glacier itself. So and then transitioned. So we can see this throughout the Tephra records and sort of trace that back and work out what exactly went on. But yes, it did progress over time, getting more intense, and then slowly sort of fading out.
So what kind of impact has that had? I mean, we're talking here, 1,000 years ago. The impact of that on the landscape around it's still evident to this day.
Absolutely. Yeah, the impact on this landscape, it has changed the entire area. Icelanders were only sort of in the country, settlers were only in the country for just under about 100 years before Eldgjá happened.
It's a bit of a shock to them.
A very big shock. So yeah, we had...
What have we done?
Yeah. They sort of, I guess, reconsidered where they were deciding to settle.
Yeah.
It pushed many people out of their settlements, especially in that Southern Highlands area. We had 2 massive lava flows coming down, producing some big pools down in the lowlands, and really pushing people away. And yeah, it also devastated the area in terms of covering it with ash, and also lots of other volcanic pieces.
Yeah, because I mean, these people, of course, they would have been, just scraping by, surviving anyway. It wasn't exactly the easiest place to live at the best of times. And that's certainly not the best of times.
Yes, yeah.
When you're reliant on animals and crops and stuff to actually kind of...
Yeah, I mean, the area itself must have been absolutely uninhabitable. No vegetation for livestock, and the entire duration of the eruption, you're experiencing infrequent of ash and gas emissions, which is definitely not healthy at the best of times.
No.
Even with some of the smaller eruptions which we see, we have to warn people of the health effects of gases and also ash particles in the air. And so with something like this, it's very, very hard to stay strong and survive in areas.
Yeah, so this is on an order of magnitude of something that we just haven't seen here since that time?
So we have seen eruptions around this same area since then, of similar magnitudes. So we have seen the Laki eruption, which was a fissure eruption in the 1700s. And it's about 25% smaller than Eldgjá. So it's big, but smaller. This then it killed off about 25% of the population of Iceland. So a quarter of the population died due to famines and also just health impacts from the gases produced. And it stretches even further than just Iceland as well. We can see these impacts all across the globe from eruptions of this sort, big effusive eruptions here in Iceland.
But like I said, we're talking here, like I said, about something that happened about 1,000 years ago.
Yeah.
How, because scientific observation was not exactly at a high point at that stage in time. So how do we actually know how this panned out? How do we know what happened at all?
Yeah, so with eruptions, Luckily, they leave a nice big scar on the landscape. So we can see this massive long line in the landscape produced by these eruptions, dotted with craters, cones, and canyons, massive ravines, which the lava, so magma pushed its way out through. And that's our first sort of remnants of the eruption. Then we also then look into records back into history and try to link these features to something which someone has written. So we do have accounts from the Eldgjá eruption believed to be in a Norse poem called Völuspá, I believe it's called.
Yes.
And we also have written accounts in the Book of Settlement here in Iceland.
Okay.
And so that,
book.
yes, that describes people moving away from this area based on a massive eruption and lava flow coming into the area. So definitely something which we can start to sort of fit the jigsaw pieces together.
It's got to be quite different, though, and when you're dealing with kind of physical evidence that you could see to this day, compared with kind of historical accounts. How reliable are they? Are they just a kind of useful tool more than solid fact?
Yeah, we really have to take them with a pinch of salt, really, especially given how old some of them can be. So Völuspá is something which we really have to be careful when we're dealing with. It's quite vague. We don't get much description on dates and length of the eruption, and also area that it's coming from, really. So it's only from really delving into the history surrounding that poem that we can start to link things up. But if we travel a bit sort of closer to us in time, a bit more to the 1700s, when we had the Laki eruption, we actually had a very, very detailed description written by Reverend Jon Steingrimsson. And he wrote almost a daily account of the eruption. And so he is considered actually one of the first volcanologists here in Iceland. He actually helped us a lot in deconstructing what happened and then reconstructing it all again.
Was this the guy that had the church down by Kirkjubæk?
Yes, yeah. He also is very famous for doing the fire mass and doing a nice sermon for people in the area and sort of easing their minds. And legend has it that the lava stopped after he gave this sermon. So it's a very interesting read to sort of look back through history and see how these eruptions affected the lives of people there, but also the detail which some accounts are written in is very, very interesting. We can actually use Jon Steingrimsson's work quite well for the Laki eruption. Unfortunately, we just don't have as well-written records for
Eldgjá. Yeah. So your focus then is very much more on the physical evidence, the geological evidence. And specifically, you mentioned tephra. Well,
yes.
First off, what's tephra?
Yeah, so tephra is sort of any loose fragment of lava which is ejected out of the volcano. So these are very unconsolidated, thrown high up into the air. And they can really range in size. We can get very, very small pieces of tephra, microscopic, either way up to about the size of a grain of sand. We call that ash. And then we can range up in size all the way to the size of a car. And then that's called a bomb, volcanic bomb. And these can all tell us different things. But yes, it's anything thrown out of the volcano explosively.
So why is that so useful for helping us to understand eruptions that have happened so far back in time?
Yeah, tephra is very interesting because it can tell us a lot about the explosivity of a volcano, how intensity changes throughout the eruption. We can also then see how much lava came out. It can really tell us a lot. We can actually use tephra as well as a date for an eruption.
Okay.
So we can look into the soil, and Icelandic soil is very special. It kind of looks like a barcode when you dig into it. So it's just stacked full of all of these layers of different colors, each of them representing a different eruption. The beauty of this, given such a big geological record, is that an eruption usually depicts an instantaneous moment in time.
Okay.
And so using these, we can actually, if we know the date of some of them, we can then look back and sort of see what's surrounding that and try to date other eruptions as well.
Okay.
So it's very, very interesting to dig into the soils here in Iceland. And they really do hold a lot of secrets.
Yeah. So how do you know then when a tephra layer belongs to this eruption as opposed to a different one? Is it purely because of that banding? Is that?
Yeah. So a lot of the time we can actually look into an area's eruption history. We know from historical records what happened, and then we can start to look backwards in time. We sort of start from the very top, the very modern eruptions, and then trace it all the way back. Different volcanoes all have a different composition of magma as well. So it's also like DNA of a volcano. Yeah. Everything is different. And so we can look at the color that's defined by its composition. The color can change based on the chemistry inside. And so we can actually see differences in volcanic areas based on the colors. But we can also take these samples back to the lab and get a really clear, definite.
Because radiocarbon dating is not really going to be an awful lot of help to you here, is it?
Not particularly. In some instances, it can be useful where we have rotten moss underneath the tephras.
Okay, so the organic material that's been caught up in those ash layers. So you can use that.
We can use all of that and get a pretty solid date. And we can also use other chemicals, chemical compositions as well, for elements to give us some more precise dating. But yes, it's all about this order of our eruption. And we have to really be careful when, especially in the field, naming different eruptions. We can only really come back to the lab. And that's when we can start to really look into which eruptions occurred when. But yes, it's very, very interesting to see all of these.
So this is basically what you're doing now. You're kind of, if you like, reconstructing eruptions.
Yes.
That just seems to me to be an incredible challenge. Because I mean, obviously, yes, you've still got that physical evidence around, but trying to kind of figure out the order of things and the how it all looked like. What kind of data is going into that reconstruction? What was it what does it actually mean to reconstruct? So
I mean, reconstructing it's a bit of a loose term. We can do our best to sort of have a look at what an eruption may have looked like. So the first thing that we would do is actually look at the thickness of a layer. When we're in the field, we can measure this thickness and cover an expansive area which has the same tephra layer in it. See how that changes over time, over distance. Sorry. And then by looking at this, we can actually look at the trajectory of the ash cloud, which came out from the eruption.
Okay, so you're figuring out the weather conditions at the time, as well as the actual kind of what the physical eruption itself was looking like.
Yeah, so we can see the weather quite well. We can see the wind direction, and then we can also see you can infer how high the plume actually rose based on how big some of our pieces of tephra are across an area. You can also see changes in intensity of the eruption as well. over time. We have this nice cake layer, but sometimes we can change from very, very small grains to very, very big grains, or the opposite way round.
So what is that grain size actually telling you? Is that telling
Yeah.
you about the explosivity of it?
Yeah. So more explosivity and intensity.
Okay, so what gives you tiny grains? What gives you big grain?
So yeah, if we move further from the vent and we have big grains,
Mhm.
it was quite intense, but we have a lot of what we call fragmentation, so breaking up of the tephra, and that gives us small grains as well. So so if the eruption actually is more intense, we tend to get more of that breaking up, that fragmentation. So we do see these smaller grains appearing. We get more of that ash component
Yeah.
of our
The
tephra.
spread of that for something the size of Eldgjá must have been considerable.
It was
Like
huge.
how far is that tephra actually traveling? Do we
Yeah.
even know?
So we can see, I think it's in Miva, we can see grains of Eldgjá tephra all the way even to the East Fjords. Down, I believe I've read a paper where it's included near to Selfoss in a lake called Hestvatn. So it did reach pretty far. We don't know the full extent of this because a lot of it went into the sea as well.
Yeah.
Which is a bit of a pain for us because we cannot find it and it got washed away. So you have to really estimate with that. But yes, it's something which is sort of beyond comprehension, really.
Yeah.
Especially when you think about the amount of tephra and also the amount of lava at the same time. It all comes together in this one big package of chaos. Yeah.
And from that chaos, I mean, you're trying to extract sense from that chaos. So it must be quite difficult to be in any way particularly precise with it.
Mm-hmm.
How much of what you're doing is kind of educated guesswork? You know, it must be quite hard to be really precise.
Yes, we have to always give an uncertainty and a possible sort of
Margin
amount
of
of
error.
leeway.
Yeah.
Yeah. So it is very, very difficult to say with certainty, especially for an eruption of this length of time, being this far away. Something which was closer, yeah, we can say with more certainty. We can actually link the records up. But with Eldgjá, it's still one big mystery, which we'll try to unravel. But something like the Laki eruption, we can actually link up our analysis of, say, a plume height to the descriptions from Jon Steingrimsson, and we can actually work out where he was stood whilst he was writing his diary, where the mountains are in relation. If they reached a certain height, then they should be visible over certain mountains. So we can actually, if we can see that the plume height is of the same, then we can link the two together.
Something of this kind of significance that has been, I mean, it must studied a lot clearly over the years. If I know anything about geologists, they're not very good at agreeing with each other. So,
yes,
there's got to be a certain amount of debate around things as well. Are you able to tell us any of the kind of big uncertainties or big debates surrounding Eldgjá?
Yeah, there are a lot of debates, and yeah, as you said, with the uncertainty, it fuels those debates quite well. A lot of it comes from actually when Eldgjá happened. We know it happened in the 930s, the 930s, but we're trying to really pinpoint those dates of how long this eruption actually took. Some say it may have taken 4 or 5 years. Some are saying more about 3 years. Some even say shorter than that. At the moment, I believe the most agreed upon is about 3 years of duration, but it's still very much questionable. We have to really look into ice cores as well to work that out, and to see responses to sulfur in the atmosphere and ashes in the atmosphere. But as I said, there is still a lot which needs to be done for this and many of the eruptions around Iceland as well. So much debate going on.
Is there anything that has personally surprised you while working on stuff?
I think it's going to sound really simple, but just the sheer size of it. It's I started out studying in my bachelor's an eruption on Reykjanes, and the size of this absolutely was dwarfed by Eldgjá. I was studying an area for my master's thesis, and I ended up finding the Eldgjá tephra in this area, and it was still about 30 centimeters thickness.
What?
So yeah, this was about 20 kilometers away from the vent, the main vent of Eldgjá.
Whoa, 20 kilometers away.
Yeah.
You're still getting a 30 centimeter depth. Wow.
Yeah. So digging up that and finding grains which are like the size of marbles, not bigger, was crazy. Yeah.
From that distance.
Yeah. So yes, it's very surprising. It sounds very simple, but the size is just on a scale you really have to see to believe.
You try and throw a marble, you know, 100 meters.
Yeah.
You know?
Yeah.
Oh,
yeah.
That is quite astounding.
Yeah.
Wow.
Yeah. And I mean, the landscape left behind by this is just crazy.
Yeah.
You have the main area of Eldgjá. It's this massive canyon. I mean, Eldgjá itself, the name is Fire Canyon or Fire Chasm. And yeah, the main feature of Eldgjá is this 8-kilometer long chasm, which is just steep sides. I'm not sure how deep it is. It probably is maybe 50 deep, maybe a little bit less than that. And then just massive lava flows surrounding it. They can be up to about 4 meters deep, if not more. So yeah, very, very big.
Okay, so I guess the question is, why is it important for us to understand eruptions like this? What's in it for us today?
The importance of understanding an eruption like this is because we don't know when it will happen next. This area in particular has seen very, very big eruptions in the past. We've had the settlement eruption, which occurred in about 870 AD. We then had Eldgjá around 937. We also had Vedava in 1477 as well, which is another massive eruption with a huge amount of tephra produced for that one as well. We also then had Laki come from there too. So this whole area in a span of a few tens of kilometers in width, it all produces massive eruptions in history. So it's something which we can't ignore. Because
it's been a long time since we've had something on that kind of scale.
Yes, and we've never had it during modern times. In terms of with modern day technology, modern day civilization, how would we respond to something like that is the big question. And even globally, as I said, we had effects reaching all throughout Europe from gas emissions, and then also in the Middle East, I believe we also had some records from the Eldgjá eruption. Sort of on a scale not too much. It's slightly smaller than Laki. Laki was very gassy. But yes, it's something to always understand. So in the future, if things were pointing to an eruption of this scale,
which at the moment they are not.
They are not. Yes, I would like to clarify that. But if things did point to those directions, we would be able to know what to expect, and how we can then implement that impact into like a hazard planning. It is very important.
Yeah. I mean, how prepared do you think Iceland is right now for something like this?
Ooh, this is quite a tough question, because it's something which the frequency of these eruptions is so small, that it's something which we haven't really considered at the moment. And I guess there's not much that I'm aware of in place for if something of this scale were to happen. It would be a big learning curve for a lot of us, adapting to something of this size. Yeah, just I would expect we would manage, but to what degree is very hard to say.
Yeah. Because I mean, even things like Eyjafjallajökull in 2010, which you said is on much smaller scale.
Yeah,
that was still having impact on life in the capital area.
absolutely. Yeah.
So a small extent, but it still was impacting. But that is like, on a completely different scale.
Yeah. So I mean, it's something which it's nice to sort of realize that we have come a long way in volcanology. We have a lot of monitoring equipment now, and back in the 900s, we did not have seismometers or anything measuring ground deformation and gas levels. And so these main pieces of equipment will actually hopefully be able to tell us something, but well before it happens. And so we can sort of rely on that to give us a bit more warning.
Because there must have been, prior to happening, there must have been significant signs that if people had been able to kind of clue themselves into them in the way that we can nowadays, then things might have been a bit different.
Absolutely, yeah. I think we have a very good monitoring system in place now. Something which can definitely, we can give ourselves enough warning time for all of our eruptions on the Reykjanes Peninsula. We can evacuate people very quickly there, even in a span of a few hours, if not, under an hour. And so for something like that, we would be able to help out. Luckily as well, these eruptions of this massive scale typically occur in the Southern Highlands, so quite far away from major population centers. So yeah, in terms of actually people being close to that area and being able to be able to believe, it's quite nice that there isn't too many pieces of major infrastructure in that area. But we still have to consider it. We still have the town of Kirkjubæ close to, and also depending on where the lava flows, it could even go a bit closer to others.
And you've got the ice to worry about as well, of course.
We do, yes, yeah. So the ice is always a big problem when it comes to volcanoes. So yeah, that it helps the lava to fragment and break apart. So we get a lot more ash. So as we saw with Eyjafjallajökull, we actually had a period 3 weeks before the main eruption where we had a nice effusive eruptions. This is a lava producing eruption. So just some nice lava fountains, lava flows. It actually became known as a tourist eruption. But as the magma moved underneath the ice towards the summit crater, that's when problems
changed
started.
the picture quite considerably.
Yeah. So we then had all of this lava breaking apart, fragmenting, and tiny pieces of ash, and then they were able to be dispersed all across Europe and unfortunately shut down lots of things. So in terms of ice, big problem for us if any of the fissures were to extend into a glacier, we then know that we have a bigger problem on our hands.
Because you've got, of course, with the flooding side of things as well.
Absolutely, yeah. So you can, just was huge deluges of water coming down into the lowlands. It's quite terrifying to really try to fit all the pieces together, and try to also put yourself in the shoes of someone living during that time. I mean, it must have been absolutely terrifying. You've moved on to this island. You're, you've people have only been there for around 100 years or so, and suddenly all of this chaos coming.
Imagine it.
Yeah.
Wow. So, just going back to the research that you've been doing, the actual kind of field work, because you have been doing a lot of field work.
Yes. Yeah.
What is that field work actually? How does that pan out? What does it look like doing field work, like tephra research? And
so I mean, it sounds really nice and glamorous, but I can tell you it is not that glamorous. But it is incredible. So a lot of it involves just heading out into the middle of nowhere, usually, and then trying to find data. So for what I look for, the tephra, I'm usually digging plenty of holes across a massive area and essentially reading that barcode, what I was talking about earlier. So looking at all of the individual tephra layers, measuring all of their thicknesses, any differences I see in colors as well.
I'm just trying to imagine you kind of like tromping out into the middle of nowhere, this huge expanse of nothingness. It's like, yes, I should dig a hole.
Exactly. Yeah. So usually it's just a case of finding a nice place for a hole to dig. So typically this is on the side of a small stream.
Okay.
Or we have these really
so you're using natural features to help you along.
Absolutely. Yeah. So we have also features which are produced from soil erosion. We have plenty of that here in Iceland with the wind. And so this can create like a nice wall of soil where some of it's been blown away. And we can actually just dig into this wall and see all of the stuff which has been left behind. And so it's quite a dirty job. You have to really like get into the mud and really sort of you're feeling the tephra grains as well with your fingers. Really, like, they can tell you a lot about the grain size. You can really see if the grains are fitting into your fingerprint. It's really quite muddy stuff.
And you're not heading off to a hotel room that night either.
No.
Existing out there for how long at a stretch would you generally do?
So for my master's fieldwork, I did a few sets of 4 to 5 days, but it can be longer than that. I know some people who like to stay out for a couple of weeks, if not even longer. So a really intensive study can actually be a few months. So sometimes it's camping in a tent. Sometimes we're lucky enough to have mountain huts nearby. So we can actually have some form of a bed, which is very, very nice. But for me, it's mostly been camping at the moment. There isn't any hut nearby which I can use. So it's very humbling, but also there's a beauty to it. Staying out in the middle of nowhere, really relying on what's around you.
And you've got the weather to contend with.
Yes.
Oh heavens, that must be one of the biggest challenges of all.
It is, yeah. I mean, in Iceland, we're very, very limited in our field season. So typically only the summer months where we can really do proper field work for the tephra. The ground just becomes quite frozen for digging, so we can't really use the winter months, unfortunately. So we then have to rely on a good summer as well. Plenty of rain can really affect things. You can get quite washed out some days. And
you must have had some pretty testing moments where you've just been on the edge of just saying, yeah, hang this.
Yeah.
I'm done with this nonsense.
Yes, yeah, you really have to dig deep when you're in the field.
Yeah.
Yeah, there are days where things can get quite wet, quite windy as well.
Any specific day that you can think of, or you?
I the first day of my field work this summer was we went to our camping site, had to cross this massive river, about 100 meters wide, in my little Suzuki. So that was quite terrifying to begin with, but we dug about 2 sections and we ended up just calling it a day because it got too wet. It was getting to a point where my notebook, which I'm meant to be able to write in rain, started not wanting to work. So the pencil was just ripping the pages open. So I had to just end it there. And then the next couple of days after that, I mean, it is very, very Icelandic fashion. We had a heat wave.
Oh, of course.
So we had beautiful weather around, like just below 20 degrees Celsius.
Wow.
It was amazing. Yeah, nice blue skies.
On days
views.
like that must more than make up for it.
Absolutely. Yeah.
Just being out in that kind of landscape on that kind of weather.
Yes.
There's just nothing like that.
It is. I mean, you're walking around, you have the scenery around you. It really is quite something. As well, being in certain areas, you can go days without seeing another person. I mean, you have multiple people with you as part of the field work, but you see no one else externally. You do go a little bit stir crazy because of that. You really have to enjoy your company, and there is a real camaraderie with it all. Everyone's in it together, and ultimately you are, even in the worst of conditions, having a good time. When you look back on it, you think, we did this really, really well, and we pushed through. It's something you have to always reflect upon after you've done field work. What went well, what didn't go so well, what can we improve upon next time? Definitely a big learning process, but something which, the memories will never leave. It's some of the best summers I've had is doing field work here in Iceland. Yeah.
So are there any particular kind of big questions that you're now trying to answer in the research that you're doing? Anything that you can actually tell us about it?
Yeah, so a lot of the questions we're trying to answer is actually sort of piecing together what went on when. We have this potential 3-year span, and the tephra of Eldgjá is quite different to our traditional tephra in that we have one big, as I said, in some areas 30 centimeter unit, even some areas up to 5 meters of it, close to the vents. But there are different layers in between. And so they can all tell us something different about what happened and when. And so reconstructing this to be able to tell us sort of which parts of the fissure was active at certain points in time, what order they were active is very, very useful for us. And also, determining sort of how big certain events of that were. Yeah, so it's one big puzzle, and we're only fitting in a small, tiny piece of it. As doing sort of volcanology here, that volcanology covers a big range. So I'm only looking at the tephra, of course. Some people look at the lava, but then you can also go into depth and also look at the chemistry and the physics behind what's going on underneath the ground. So people use gravity, magnetics, deformation. And so it's only a very small part of the jigsaw puzzle. I keep referring to that, but it's something which you have to collaborate on all sides to really fit everything together, and to get that broader understanding. And then once everything does come together with the best that we can do, that is then what provides a really good hazard assessment and we can actually convey that data to the public in a way which they can understand as well. That's also part of the puzzle too.
So if somebody was kind of out hiking in that area just now, like what would you want them to understand about what they're actually standing on?
I think, yeah, I'd want them to understand the power of Earth.
Yeah.
This is this is the biggest effusive, biggest eruption really in Iceland in historical times. It's a landscape which, if you don't really understand what happened there, you might just gloss past it because it did happen a while ago, and so some features are eroded away.
Yeah.
But it's always that understanding of how powerful things can be, and that we are very, very small in comparison. Standing within the Eldgjá Canyon, and you look up either side of you see these massive towering walls and lava bombs all sort of along the floor. It really is, it makes you feel very, very small. So yeah, it's just about understanding how small we are in comparison to these events, but also that we can understand them. Yeah.
So I'm just going to wrap this up now. If another Eldgjá eruption were to happen again tomorrow, what would worry you about it the most? And what things do you think would be better prepared for?
I think we would, as I said earlier, we'd be better prepared in terms of monitoring. We'd be able to hopefully understand when it's coming, or a better understanding of when it's coming, and also where we would have an eruption. I think what would concern me is that we are obviously, the country is growing. We have tourism here, and people are visiting these areas. We even have it with the smaller eruptions on the Reykjanes Peninsula that they're visiting without too much knowledge on what they're approaching.
Yeah.
The perception of a volcanic hazard has very much changed in the last few years, and so in a good way, people are less fearful. They know that we, as volcanologists, they have it more or less under control now in terms of hazards, but there are
also less
exceptions.
careful.
Yes, and they are less careful. So that would be quite concerning, and how we deal with that is something that's yet to be seen. As I said, it's on a scale which we haven't experienced yet, and so everything which comes from that will be fresh. How we warn people, how we work around it, but also the amount of stuff that's coming out, and also gases, ash as well. We're not sure how that would impact a modern day society. So that still very much needs some work to really understand what could be impacted. We also have areas in that part which are sort of a powerhouse of the country. So a lot of the power from hydroelectric may also be affected too. So yeah, it's something to really consider and be aware of.
Well, on that slightly chilling note.
Yes.
Sleep well, folks.
Yes, yeah. These big eruptions, they can be quite terrifying, but at the same time, as we said earlier, we're not seeing anything that would suggest we have anything to worry about as of now. It's always a case of living alongside it. Alongside the eruptions and the volcanoes at the same time. It's about respecting what they do, and also just learning to adapt, live alongside them. Yeah. So.
Wow.
Yeah.
Well, that was absolutely fascinating. Thank you so much, Glenn, for coming in and sharing about your work and just kind of filling us in on the picture of this incredible period in history.
Yes. Yeah. Thank you very much for having me. Great.
No problem at all.
Thank you.
Thank you. So massive thanks to Glen for joining us on this episode. We hope you enjoyed it. And if you did, be sure to tell your friends, share the good word about the podcast here. And if you haven't already done so, make sure that you subscribe to us. And if you do have any comments or you want to get in touch with us for any reason, then you can get in touch with us at podcast@lavashow.com. And of course, you can find us on all the usual social media platforms as well if you just search for Lava Show. So thank you very much for joining us, and we'll see you next time. Bye for now.